Hi everyone. So thank you for watching this video. I'm so sorry for giving you a short notice to changing class lecture to video lecture. I'm sorry. Okay, I'm sorry for any inconvenience caused by me. Okay, so thank you. Thank you for your understanding. Okay, thank you. Okay. So last class we we discussed to estimation how to estimate population's population's average. So usually we will give a confidence interval for mu. We will say mu will be in this range, right? We have some confidence to say the average for all people or average for population is between there's two numbers. Those mu is in this such an interval. Okay. So we have the formula, right? We say says mu will the confidence interval is x bar. So x bar is the sample's average. So plus minus plus upper bound minus lower bound plus minus. So C star times sigma over A. So here we say this is the x bar here. So the interval is just like that. Okay, so plus this minus this. So we also call this sigma over radical n as standard error. So this Z star is the cutoff point from table, from normal table. Like if we say find, let's say 92% confidence interval, so this means that here 0 from here this interval is 92%. Okay, so this cutoff point is Z star. Right? So how to find this star from the table? We say so if this is 92, then all the way down is 96, right? Because 4% here, 4% here. So we should check 96, 9600, right? So from the table, we just check neighborhood for this. Then we can determine this cutoff point is this star, right? So this in this formula, we say this sigma. We assume we know. Now assume that if we know, so we know sigma. So from sample, we know sample mean x bar and sample size n. And from table we can find z star. So so this sigma we say is assumed we know this, right? So sigma is assumed to be known. But in real situation, sigma is unknown. Okay? So sigma is unknown, so logically we cannot use this formula. We cannot use this formula to estimation. Right? So then how can we estimate the population's mu? So let's check a simplest case, how to solve such a problem. So we usually check a simple case first. So simple case, so simple data or simple population is 1 0 population. We say 1 0 1 0. Okay, so 1 0 population. So typical situation for 1 0 populations, some people say yes, some people say no. Only two options, right? So we check it out, say yes, we denote yes is 1, say no is 0. So to describe this population, we use this distribution, 1 0 distribution, right? So x, if we pick some guy from this population. So this guy maybe say yes or maybe say no. So only we don't know is the probability for say yes or for say no, right? Or we say the percentage for say yes, percentage for say no. So only thing unknown thing is P. Okay. So we have many examples for such a situation, like just yes no question. If we do a survey, ask a yes no question, we can get those things. Like some people say yes, some people say no. Like for example, for the presidential election, whom we will vote? Suppose we have only two candidates. Like you will vote for this guy, or you will not vote for this guy, right? Okay. So for this, we say for this simplicity population or simplicity distribution, we know sigma of sigma square variance equal PQ, and sigma is PQ take square root, right? So we already know that. So for this situation, we have simple formula for sigma. Okay, and then so okay. So if we from such a population take a sample, so that's the sample for data. Data is also we call 1-0 data. Right? So some people say yes, some people say no, some people say yes, no, or no, like other data like that, right? If we do a survey, data just like 1-0 data. Right? Some people say yes, some people say no. So from this data, we can find percentage for say yes, p hat. So we say p hat equal, let's say among how many say so number of yes, how many say yes, so right. Okay, so this is p hat. Okay, so then from here, so we can have an easy way to estimate this sigma. So we have this. We say sigma hat. So here hat means estimation, right? So sigma hat, we can use this. We call p hat q hat. Okay. Okay. So now we can have those kinds of formula. So let's say, so for this formula, like before we say x bar plus minus c star, so sigma over radical n, right? So now we changing this. What so x bar? So what is data? Data is like 1-0 data. 1-0, 1-0. So average add them up divided by n. So we found this average, just add them up divided by n is just the number of ones over n, just a p hat, right? So we say here x bar is p hat. Okay. So plus minus. So we keep this stuff. Then this sigma. So sigma we can use this. We call p hat q hat over radical a. So we can have this formula for population's average. So if the population is 1-0 population, then the population's average, 1-0 population's average is just this p, right? So we call this as a proportion. So we can say that p is a probability before we say probability for say yes, or percentage for say yes. But in statistics, we give a name for this P. We call P is a proportion. Okay, so okay, so we put it as P. We say P is a proportion. Proportion. That's a typical name for those percentages. Like just for the 110 population's percentage, because it's as a proportion. The population's proportion. So we can regard this formula as confidence interval for population's proportion. Okay, so this one we can say for this one is for mu population's average. This one is we also can say the P is average, but this is a population typical average. So we say there's a population's proportion. Okay. Okay. So we say like do a survey is a really common story in our daily life, right? So for marketing surveys, we just check how many people or what percentage people like our product. We just do some marketing surveys, right? And for election, we wanted to predict who will win the election. Then we just do a survey like like by now we have midterm election, so many agencies just do some polls. Okay, so they are say, oh, like let's say like let's say like they do a survey, so they tell us this guy's percentage is 42, this guy's percentage is 40, then we can predict this guy will win, like that, right? Okay, so now let's consider this example. Can we predict this guy will win? So here, suppose we have only two candidates. So this guy will win. So win means true percentage will be larger than the true percentage or true proportion will larger than half, suppose 50%. So actually, like in real situation, true percentage cannot be larger than 50, right? Because many people will not vote. But here we just assume make things simple, like if and we have only like because we have not only two candidates, right? We have several candidates. So here we just make things simple. We have only two candidates, and everyone will vote. Everyone will say yes or no. Okay. Then the guy, if the guy's proportion is more than half, then this guy will win, right? So we say, so for voters, so for populations, so here's huge, right? So we cannot check many people. So let's say we just check, suppose we check 1,000 people. We find among 1,000, 520 will vote for this guy. So here we get this. This percentage of proportion from sample from our survey is this, right? 250 over 1,000 equal this, right? Okay, so this one, so we have evidence. This one is clear larger than 50, right? So we will evidence that shows this guy will win. But the question is, this evidence is strong enough, or can we, based on this evidence, to predict, to claim this guy will win? Okay, so to solve such a problem, we wanted to find, actually, we want to find 95% confidence interval. Okay, we want to find 95% confidence interval for true, for, we cannot say true, like, for percent population's proportion. If population proportion is larger than 50, 50%, then we can claim this guy will win, right? So otherwise we cannot predict this guy will. So to answer this question, so let's construct a 95% confidence interval. So this confidence interval, we can use the formula, right? Equal p hat. So I just plug it in. P hat is 0.52. So plus minus. So this star 1.96, or can be 2, right? Multiply. So here sigma become thus. Let it go p hat q hat. So equal p hat is 52, saying q hat is 48. Okay, right? And divided by n is 1000. Okay, so now we just need some calculation. Yeah. So low bound, upper bound, right? So we just do so calculation. So let's say, let me do this. Okay, so okay, cool. Okay, so from my calculation, this equal 0.488, and upper bound is, let's see, change this to plus. Okay, 0.552. Okay, so we can say we have 95% confidence to claim that the true populations proportions between these two numbers. Okay, so here is 0.50. Okay, so the interval is just like that, from here to here. So mu proportion will be in this range. Okay, so from the interval we can say this interval is not clear above 50%, right? So this means so above 50, this means like this guy will win, and below 50, it means this guy still can lose the election, right? So here we say if the so we can say this evidence like this 52 or this evidence 52 is larger than 50, but this evidence is not strong enough. So based on this survey or this poll, we cannot predict this guy will win. Okay. So the answer, can we have 95% confidence to predict he will win? We say maybe not. Okay. Okay. So we have those kind of problems. So we call such a problem in statistics is a proportion estimation, or estimated populations of proportion. So basically just estimate percentage for all people, right? So we have many of those kind of problems. So let's check this one. Let's say we want to find what is the percentage of people or vegetarian. Vegetarian means not eat meat. So we just do a survey. We just check 100 people. So here n equal 100. We just check 100 people and got the result. Let's say 15 people say yes, right? So we can say this percentage from sample is 15%, right? Yeah. So we call this percentage, or we say this proportion, or this is sample proportion. So we have sample mean, sample proportion. So this sample proportion is typical mean. The data is 1-0 data or yes or no data. Okay. So then we, based on that, so we wanted to, let's say, so give a 90% confidence interval for P, the proportion for all. So we want to check. We want to find a percentage for all people. They are vegetarian. So maybe school needed this information. Right? They wanted to prepare their food. Okay. So such a problem. So we say we can use this formula, right? So P hat plus minus C star sigma. Oh no. So sigma become, by now we just replace sigma by radical PQ. Radical P, but there's a P hat, Q hat, right? Okay, just like that. Okay, so here, so we just plug in what is P hat? 15. So plus minus C star. Okay, so saying n equal 100. So P hat, Q hat, the P is 0.15, Q is 0.85, right? Yeah, 1.85. P plus Q is 1, yeah. Okay. So we have everything except this star. So this star we should check from the table. Okay. So let's say this star is like this, right? Okay. 90%, right? So 90%. Okay, let's say 90%. So here 0. So from here to here is 90%. So this is this star. So for checking table, so all the way down, less than this star is 95%, right? Because 90% is inside, outside we have 5%. So we call this left tail, right tail. So left end, right end. So we need to check 0.9 9500, right? We need to check this. Check this one. So we can find the neighborhood. Okay. So I think I remember this star should be 1.64, 1.65, right, or 1.645. So either one is okay. So we can say this star can be 1.64 or 1.65 or 1.645. So either one is okay. No big difference. So here just plug it in, right? So let's say we just plug in this star as, let's say. If we use Excel, maybe I put this one more precisely, right? Okay. Radical 100 is 10, but as a formula, I just put this formula. I use Excel, use calculator, doesn't matter, right? So here just so by now just some calculation issue. Okay, so equal. Okay, so let's do this. Okay. A little bit of calculation from calculator. From I prefer use Excel. Yeah, for me I prefer use Excel. Okay, so let's say equal 0.15 minus 1.6. Okay, so equal low bound is like 0091. So upper bound, let's see. I just change this to plus. $2.09. Okay, so we can find the confidence interval. So here actually, like let's say if we do a survey, this sample size like in 100 usually is too small. Like let's say for this example, for a particular election, we check 1,000 people. This 1,000 people is also not so big. So because like not so big, because compare with we can imagine compare with all voters, all people's million, right? Hundreds of million. So this 1,000 is just too tiny, too small. And also here we have other issue, like by now. But anyway, like by now, for midterm election, many agencies do survey, do poll. So and some newspapers say, oh, they show this guy will win, or these polls show this guy will win. But usually, those polls, from a statistical point of view, those polls not so trustable. You see, not so trustable. So why? So this is the other issue actually. Why? Because they are check some people, pick a sample. So from theoretical point of view, this sample should be well prepared, well representative for the population, or this sample and the population quite the same. If sample and population totally not quite the same, then your survey cannot be so precise, right? So for example, like if there the survey ask most people are Democratic, Republican or Democratic, or most people are men or most people are women, then their survey cannot be so precise, right? So this is actually predicted is tough, because like if we should survey many people, but if survey many people cost too much, right? Okay. So maybe more reliable is the big data, like use computer or like use some other way, like we should use let many people involve something. Then maybe so for big data they can get a more precise information. Yeah. So this is other stuff. Okay, so from the two examples, we say, for this 1-0 data, how to estimate the mean, how to estimate x bars, and now how to estimate p or proportion is easy. Right? We just replace sigma as pq, or square root of pq, or square root of p hat q hat, right? Okay. So this issue in stats we call the population proportion estimation. Yeah. Okay, so for this 1-0 data we are done. Easy, see, right? So how about the general data, not the 1-0 data? The data like this, x1, x2, xx, those are x1, x2, xn, not 1-0. Okay? Okay. So from those data, we can find sample mean. The sample mean x bar, right? And we also have like a samples standard deviation or samples variance. So for population, we have population's mean, population's standard deviation, population's variance. And from sample, from data, we also can have samples mean, samples variance, we just say sample variance, sample mean, and sample standard deviation. So for mean, we have two means of population mean and sample mean. For variance, we also have two variance, right? Population variance, samples variance. A standard deviation, the same thing. Population's standard deviation, say population standard deviation, and sample standard deviation. Okay, so don't get confused. Okay. Okay, so let's say, how can we define the population's variance or population standard deviation, mu sigma square or sigma? So we say sigma square is defined as thus, right? Sigma square equal x minus mu square's average or expectation. Okay, and what is mu? So we say mu equal expectation or average for this x, right? Okay, so what is sample mean? So if data like this, so this average is, we say x by this. Okay, so we say mu is average for all x. So here for sample mean is just the add them up divided by n, right? So this just, so then what is sample variance? So we use this formula, sample variance. So we denote this as a square. So we reserve this a as sample standard deviation. So for population, we have like mu sigma of sigma square should be sigma square first, right? So for sample, we have sample mean, so x bar. And sample's standard deviation, we usually denote this as S. And sample's variance is square. Okay. So the formula for S square is like this. X. So we say, based on this, we say like a sigma square is x minus mu square's average. So by now, this x can be x1, x2, can be those data, right? So this is just x1, so mu is just x bar, right? So just let's say, so just looks like x1 minus mu, so mu is x bar square, right? So average, so should be added them up divided by n, right? Average for those things plus x2 minus x bar square plus xn minus x bar. So we denote this as summation sigma I start from 1 to n. So add them up. So here just divide by. So divide by n minus 1. So here we have a bigger question. Why divided by n minus 1? So average should be divided by n, right? So add them up, divided by n. Just like sample mean. Add them up, divided by n. So for sample's variance, add them up, divided by n minus 1. Okay, so here we have the question, why? Why divided by n minus 1 instead of n? So to answer this question, so we introduce this notation. A concept we call it degree of freedom. So what is degree of freedom? So just let's say, just suppose we have three numbers x, y, z, x, y, z. So data like put them together. So we have, so these three numbers are independent, no relationship basically. So each one can change freely, no restriction. So we call this data three number. This data, the degree of freedom is 3. Like each one we put 1 degree of freedom, 1 degree of freedom. Each one has 1 degree of freedom. The degree of freedom is 3. But if these 3 numbers have some relationship or have some condition or have some restriction, suppose that we have this x plus y plus z should be equal 1 or equal 0. Let's say put equal 0. Okay, so then these 3 people have some relationship, or 3 numbers have a relationship, right? Not independent. So here let's say, like if x, y are determined, then z, if x, y is giving, z have no freedom. Actually, z is completely determined by x and y. So we have the formula actually, z equal negative x plus y, right? So if we know x and y, then we can know z. Z has no freedom. But x and y can change freely, right? X, so we say x can change freely. X has a degree of freedom 1. Y also can change freely, has a degree of freedom 1. But z, no no degree of freedom, no freedom at all. So put them together. So in this case, there's three number x, y, z. Their degree of freedom is become 2. Okay. So here, so in statistics, mean or average or mean is equal sum add them up divided by degree of freedom. So not always divided by n, so divided by degree of freedom. Okay. So we can claim, like we can say, like those numbers, this degree of freedom equal n minus 1. Okay. So we can easily let's say we can prove this, or we can show this. Like we have those numbers. So let's say we have x1 minus x bar, right? X2 minus x bar, and we have then xn minus x bar, right? We have those n numbers, but these n numbers are not independent. They are dependent. They have some relationship. Okay, so this relationship we can easily say, like we find this number plus, let's say plus this number, plus we add them up, plus this number, we find this equals 0. Always equals 0. So then we can say, like n numbers, add them up is 0, so only n minus 1 number can change freely. One number is completely determined by others, right? Okay. And so why this equals 0? Always equals 0? So this is also easy to confirm. This equal, like, let's add them up. This equal x1 plus x2 plus xn. Then minus x bar or x bar minus how many x bar? Minus n x bar. So we can say this just equals 0, right? Because n times x bar, what is n times x bar? So n multiply x bar equal x1 plus x2 plus xn, right? Okay, so we say, like here for samples values should divide by n minus 1. Okay. Okay, so once we have data, so we can find x sample mean, samples values, right? So let's say, for example, like suppose data like this, we want to find sample mean and sample variance. So sample standard deviation, so take a square root, right? So this is just a calculation. So let's say sample mean x bar. So the data is this one. This is just not real data, the artificial data. So we say, oh, this is really easy, just middle one, x bar equal 5, right? So what is sample variance? What is S squared? So S squared equal each one minus average square. So first one minus average square. So 1 minus 5 square. Then 2 minus 5 square, like that, right? Then 3 minus 5 square. Then 5 minus 5 square. Plus 6 minus 5 square. And until 9 minus 5 square. So we just find this is summation square xi minus x bar square. So this number is easy to calculate. So this equal like 1 minus 5 is 4. So 4 squared 16. So this is 3 squared 9. 2 squared 4. So 1 squared 1. So 0 squared 0. And then against 1. So just 1 square, 2 square, 3 square, 4 square. 9, 16, right? So we find this equal. So this equal 10. This 20, 30. So here's another 30, so 60, right? Yeah, 10, 20, 30. Yeah. So saying this is 60 should divide by. So 60 should divide by. So here should divide by 8. So not 9. N minus 1. So we have n number. So we have 9 numbers. N minus 1. So this is s square variance equals this. And what is sample standard deviation? So just equal this. Let's take square root, right? This. Okay. So those are just simple calculations. Once we have formula, we can easily do those calculations. Okay. So from the data, so we can find sample mean, sample variance, sample standard deviation. Okay. Let's standard normal. Okay. So let's say. So it seems okay. So how about we replace samples? We replace populations standard deviation by samples standard deviation. Can we do that? So let's say before we have the formulas x bar plus minus c star sigma over n. So by now we say we just change the formula. So x bar still x bar, the sample mean plus minus. So c star radical a. So we just change this sigma by s. So the question is, this formula works? Is this formula okay? So the answer is depends. Let me see. It's okay. Sometimes it's okay. Sometimes this formula is okay. Sometimes this formula not okay. Not so okay. Okay. So we will. So when this formula is okay, when this formula do not okay. If this formula do not okay, so how can solve this problem? So this will be our next class topic. Okay, so we can stop here. Okay, so thank you for watching this video, and thank you so much. Okay, and again, I'm sorry for this inconvenience. Okay, so thank you.